So if you're going to cut the sheet of metal to make a box, you're going to make little cuts in all the corners. And then when you fold up the sides, it'll form a box with an open top. So if this is 10 by 14, that means this side is currently 10, this side is 14, all the way across. Once you make these cuts, now in order to make it a box, that needs to be the same amount cut from each side. These are going to be little squares cut out, and they all need to be equal. Otherwise, it's going to be a really weird looking box. It won't work. So you cut X from every single side. So once you do that, you get this new smaller box, and it also has a height to it. The height of that box would be X, because that's how much we're going to fold up. Once we cut off the X, that's how much we fold up is X. So if we're finding volume, which is length times width times height, I just said that the height is X. So it's going to be length times width times height, which is X. Now, this little rectangle I drew over here is actually going to have these measurements. This blue line is this length of the rectangle, of the box with the folded up sides. So here's our box. It's got a height of X. This little inner portion here will be 14 minus what we cut off. We cut X from each side, so this is going to be 14 minus X from each side. That's minus 2X. That's our length, 14 minus 2X. Then the width here would be this measurement, which is the 10 minus the X that we cut from each side, so that's 10 minus 2X. So the width is 10 minus 2X. So there's our polynomial equation. We replace length with what it is, width with what it is, and height with what it is. If the volume of the box had to be 80 cubic meters, what are all the possible values of X that could be cut off from each side? So we're going to take this equation, we're going to set it equal to 80, and we're going to do that with our calculator. We're going to go to our graph, we're going to type it in. It was 14 minus 2X, 10 minus 2X, and X. So parentheses. There's our volume function. I can draw it right now. We won't see much, depending on what your window is. You can change the window because we can't cut a negative length. So we can change that to be 0 to, oh, let's go to what our biggest dimension was. I think it was 14. That'd be plenty. And our Y represents the volume. So, I don't know, we'll go pretty big. Can always change it. I'll go 200 for now. So there's our polynomial function. We want to know when it has a volume of 80. So we want to know when our graph equals 80. So we're going to go gsolve. We know the Y value we want, so we're going to set it to do our X calc, because we know the Y value has to be 80. And we're going to get 3 answers for that. First one's 0.754. Our next answer is 3.365. And there's one more answer here of 7.88. Now, the 7.88 you cannot actually do because it's how far we're cutting into the box. If you cut 7.88 meters into the box from the right and 7.88 from the left, you just cut off an entire side of the box. You went more than the 14 total. You can't do that, especially if you go the shorter way, which you'd have to go that way too. You have to go 7, cut 7 up and 7 down, and you've definitely cut off the whole side of the box. So that answer doesn't make any sense. You can't cut more than halfway into a box, otherwise you're just cutting all the way through the box. So you got 3 answers, but only 2 of them are possible. And then using these, we need to state the possible dimensions of the box. Well, we know length is 14 minus 2x. X. We know width is 10 minus 2x. And we know the height is just x. So our dimensions for the first possibility are 14 minus 2 times 0.754, 10 minus 2 times 0.754, and just regular 0.754. So you do 14 minus 2 times 0.754. Here's a cool little trick. Go back to that 0.754. If we leave it right there, that'll be saved as x when we go back to our main portion of our calculator. So if we do 14 minus 2x, it'll use that 0.754 for x. Makes sense. It's about 2.5 or 1.5 when you subtract it off. So 12.492. And we'll do 10 minus x, or 2x. 8.492. So here's one set of dimensions. The other set of dimensions we're just going to get from using our other x value, 3.365. So if we go back to the graph, and get our xcalc back. Could have also just typed it, doesn't matter. There's our x value. Go back to the main portion, and now we can just do 14 minus 2x. And 10 minus 2x. Or you could have typed out what it was without having it stored as x. 7.27 and 3.27. So there's our other set of dimensions. So 2 different boxes, the volume would be 80 if you multiply those out.